Hello, so we are back, and this time we have a nice laptop to repair. Check here, HP Zbook i7 Zbook 15G3. Now the customer, it's a computer shop, I believe. Now let's see what the customer is saying. So the customer is saying power light it's on, but will not turn on. Try normal style, like removing the battery, etc., but nothing working. So indeed, I did plug the charger, and we have the. It's taking no current at all, nothing. But we do have the light. Oh, you can see. So it is taking some current, but we can't see anything on the power supply. Pressing the power button, nothing. No current consumption, and it's not coming on. Now let me open this quickly, and let's try to have a look inside to see what can be. And the back cover, it's out. Okay, that's an interesting design. So we have a dedicated GPU chip also. What is this? Oh, this is some card thingy, right? Yeah. Now, the charger is plugged. We have here like big two inductors. We can check if the voltage is getting into the laptop. And check on the screen, 19.5, okay? Now the main power rail, if it's present, coil, Mosfet, capacitors. And the main power rail has 4 volts, and the voltage is changing. Check that. I will say, let me take the heatsink out just to make more space here. We have, oh, that's nice. Check here. So the GPU, it's actually a card. I mean, the laptop used to be like that. You know, you can just swap the GPU card, and also you can upgrade it. Yeah, on the past, like 15 years ago, 10, 15 years ago. So check here. Huh? I mean, you know how easy it is to reflow this GPU chip? Like 1 minute. Yeah, looks like this was never opened before. Pretty nice, pretty nice. Now, let's see. What do we have here? Here we have a bunch of power supplies. Now, just to be sure, let's check one more time the main power rail. Like we can check here. And we have 4 volts. Now, I don't think it's anything shorted here, just because it's 4 volts. It's 4 volts and it's taking no current. We can unplug the battery. I unplug the battery. Let's check without the battery. So without the battery, same story, like 4 volts. So nothing is shorted. What I'm looking is to get into the input power circuit, which has to be after those inductors somewhere here. Probably it's on the other side of the board, so most likely we have to take the board out. Just give me a little bit of time to take the battery and the board out. Wow, under the SSD we have a bunch of Mosfets. I think we can start from there. Yeah, let's go under microscope. We have access to the BQ chip, lol. That's perfect. And I believe the input circuit is here. Check here. One MOSFET, second MOSFET. Charging circuit must be here. Ooh, beautiful. Beautiful design. So, the power should be here, right? It's coming here, 19. We can see on the screen 19. On the output of the first MOSFET, we have 0 volts. Lol, nothing. On the gate, we have nothing. BQ chip, we have the power which is coming from the charging port, and we have 19 volts, so the BQ chip has 19 volts. Let me unplug the charger. Let's check the first 2 MOSFETs. Obviously this is good, it is not shorted, and this one is not shorted. Gates are together. Yeah, the gates are together. So we have 2 channel and MOSFETs, I believe. Not sure about that. And check here the gate from the Mosfet coming nicely exactly from the BQ chip. Okay, let's pull up the data sheet of this BQ chip. So we are looking for AC detect pin number 6. We are looking for reg N pin 24. Yeah, let's check those. Pin number 6, AC detect. Pin number 6 is this one, and we have 2.6, which is fine. And reg N pin 24, which is this one, and we have 6 volts. Check on the screen. So everything seems to be fine. But why we have no voltage on the gate of the MOSFETs? Okay, let's pay attention on the charging circuit. MOSFET, let's check the MOSFETs. This one is good. This one is good. Yeah. MOSFETs are not shorted. This to ground is not shorted. So everything seems to be fine. But for some reason, the voltage is missing on this rail, the voltage for the gates. Here you have a capacitor to plus, but that's impossible to be shorted. Here a capacitor here, impossible to be shorted. But remember, we have, like last week, we have a video. So actually this gate rail, it was dragged down by some protection circuit, if you remember. Okay, so you know what I will do? I will remove this resistor. Yeah, let's do it. Perfect, so we remove the resistor. Let me cool down. Let me save this resistor. Good. Let me cool down the BQ chip. Good. Now let's plug the charger. Plug in the charger. Great. Now let's check the voltage there. So the voltage here is 0. Lol. Okay. So basically it's missing. Yeah, we have no voltage, nothing. Okay, in this case, I will replace the BQ chip. And the BQ chip is removed. So this is my last BQ chip. I have to order more. We should apply some solder? No, it's looking fine. No, that's fine. That's okay. Yeah, like that. Perfect. I will dip the BQ chip inside of the rosin. Perfect. Now let's solder the BQ chip. Perfect. So the BQ chip it is soldered on place. Let's solder the resistor back. Perfect. Now let's cool down the motherboard and test. Hopefully it will work. The charger was plugged in. That's crazy. Lol. Did you see any current change? Huh? Why I'm doing these kind of mistakes? I mean, how you can solder and desolder a chip with the power on? and the bigger chip has 19 on it. You remember? We checked together. Okay, so plug in the charger, and it's doing nothing. Let's check the main power rail. And the main power rail is 4 volts. Exactly the same. I mean, nothing changed. Ha ha. And here we have exactly the same voltage. This was the Regan, and it's 6 volts, and the input voltage is 19, and AC detect is present. Lol. Okay, that sucks. Proper sucks. Okay, let me come with the power supply with above 6 volts, very low current. Yeah, 120 milliamps is fine. So we are checking. So plus on the gate, and here is nothing. Nothing is taking current. Yeah, absolutely nothing, no current. And here, and nothing. No current drop. Good. On this point, I will switch the power supply to 19. Let's go with 19 on the main power rail and see what is happening. So the main power rail has to be here. And it's fine, it's taking like 10 milliamps, lol. So everything is fine. Good, coming here, fine, no issue. Still 10 milliamps. So I'll plug the charger. Yeah, the charger it is plugged in. Good. And I will come with the power after this Mosfet here. And it's taking 10 milliamps. Good, perfect, perfect. Now let's check the gate of the Mosfet. Lol, 26, 25 volts there. I check there, 25 volts, you can see. Check on the screen, 25. And if I take the power supply from here, the voltage gets dropped to 0. Okay, let's go back to basics. So that double diode probably is this one. Fine, fine, fine. Yeah, this is the double diode. And from here is going to the bigger chip, right? Yeah. Yeah, it's going here. And this one is coming from the battery. So basically, if I short the first MOSFET, everything is working fine. Of course, we can do it. Just for the love of science, right? Yeah. Let's see at least if the laptop is working. Let me raise the current. Rising the current. Perfect. Plug in the charger. Good. Where is the power button? It's here on this side. Good. I'll short the first MOSFET. And the laptop is coming on. I can't believe. Lol, the CPU is hot. 1 second. Let me use a little bit of heatsink on this CPU. Has no GPU, lol, yeah. It's no GPU card. Yeah, it doesn't even matter. Okay, we have to fix it. We have to fix it. So the AC chip is good. Yeah, no issue. The laptop it is coming on. Good. Let's check. More things here. Yeah. So probably here it's a current sensor, and it's fine. Must be another capacitor here. Yeah, this one. Yeah, this is another current sensor, which is going straight to the BQ chip. Yeah, perfect. Then we have this capacitor, which is good. And this one, which is good. And this one and this one. Here are two capacitors to ground. You know, I can't believe I'm stuck on something like that. Okay, you know what? I want to test something else, yeah? So stay with me, yeah? I want to plug the battery and see the charging, see if it's charging. Because that's how we can quickly check the charging circuit. So plug in the battery and obviously it will not charge, but we're gonna short the first MOSFET. We have current, we have. So shorting the first MOSFET. It's taking 10 milliamps, but it's not charging. Huh? Why? And we have a loop with 20 milliamps, huh? So why is not charging? I mean, okay, something is faulty in our circuit, okay. I can understand that. But we're supplying power, so whatever is required, and it's still not charging. No, nothing. And the power supply just clicked. It's clicking. I can see. So the current limit is clicking. Beautiful. Let me grab the thermal camera. You can't see any current because the current drop is so fast. You actually can't see any current. See, that's why I love the linear power supply. I can see the LED. The LED on the current is flashing like once per second. Yeah. So we have a short circuit somewhere. Let me try to find where. Check here. Yeah, check here. Check there. There. Check there. Huh? What is that? What is that? You see? So the current which is going on whatever is there, here two MOSFETs. On the charging MOSFETs, the current which is going there is over 5 amps. You can't see the current because it's just short pulses. So that's the charging MOSFETs and the coil. And you can see the coil actually. The coil is not flashing. That means the current is not going into the battery. So the current is going through the MOSFETs. Huh? And we checked those MOSFETs and they were good, right? We checked them. 0 ohms. 0 ohms. No, so this one is good, yeah? So the high side, I think it's the high side. 1 second. Yeah, it's the high side. So this is the low side. So the low side MOSFET has 0 ohms, you can see? And that's the reason why my BQ chip is not working. Because the chip has a short circuit MOSFET detection. Now let's remove the MOSFET. So the MOSFET is removed. Let me find another one. And I found another MOSFET. I think it's exactly the same, right? 7506. And the one we took it is 7.5 of 6. Lol. We found exactly the same MOSFET. Probably this is the first time in my entire career where actually I found that MOSFET, same MOSFET as the one I desoldered. Can't believe actually I'm soldering exactly the same MOSFET. Perfect. So the MOSFET is soldered. Now let's cool down the board and test. But we checked the MOSFETs together, you remember, from the charging circuit on the beginning, and it was not shorted. Or maybe I didn't touch with the probes. It is possible. Perfect. Let's connect the charger. So connecting the charger, and nothing happened. And that's bad. So the main power rail. Main power rail is the same, 3 volts. Okay, that's fine. That's okay. Let's check. Microscope. And we have to check the MOSFETs, right? So the MOSFET is good, it's not shorted. And this one is not shorted. Then what is wrong here? Let's try that trick again. So the trick was plug in the charger and short in the first MOSFET. Short in the first MOSFET. No, actually I can come with the red wire here. So coming with the red wire here. And it's fine. You know what? It's fine. Let me plug the battery. Plug in the battery. Red wire here. And it's taking no current, nothing. I can't see a current limit, nothing. So what's wrong then? Let's check some voltages. Now we have 90. Lol, now it's working. We have 19, but it didn't work. It didn't work. But why is not charging then? One second. On the gate, yeah, we have over 25. Unplug the charger. Plug the charger back, and we have what? We have 0. It's not starting. No. It's not starting by itself. But if I start it, like, yeah, now it's staying. 19, you can see. Haha, must be something else. Must be something else. Okay, let's focus on the charging circuit. So it's still not charging. The battery is plugged in, but still not charging. The voltage on the coil here is 0. So the battery is faulty or what? You know, let's see if the laptop is coming on. Pressing the power button, and it's not coming on. Lol, it was coming on earlier. The main power rail 19, pressing the power button, nothing happened. Nothing. Unplugging the battery, let's see. Pressing the power button, still not coming on. The laptop is dead. I swear it was good before. Plugging back the charger. and it's taking 10 milliamps, and the laptop it is coming on, it's taking 800 milliamps. Check that. Wow, proper hot, the CPU. It's taking 10 milliamps. Let me plug the battery. Plug in the battery, and it starts charging 130 milliamps. Check that. That's the pre-charge current. 130 milliamps. Now it's going to 300 milliamps, 400, and so on. So the charging current is going up. So it is charging fine now. It is charging fine. You know what? Probably it is working fine. Yeah, it's no issue. That was the issue, the MOSFET. So I will do a test, yeah? I'm plugging the charger. Plug in the charger. Let's press the power button. Pressing the power button. And it's not working, Lord. 1 second, because now the main power must be present, right? 1 second. It's 11 volts. So if the main power is present, why this is not starting? The BQ chip. I mean, we have no voltage after the first MOSFET. We have 19 at the input and nothing at the output. Just, just why? I mean, this is crazy. I mean, you see, this is a point. Just a simple fault can mess up with your brain here. So plus, plug in the charger, and everything is fine now. Wait. Plug in the charger. Why is taking 4 amps? Oh, okay, because I short the first MOSFET. Yeah, I took out the thingy, and now... Yeah, no, it will not work like that. No, it will not work like that. Let me unplug the battery. Let me get the main power enabled. Plug in the charger. Plug in the charger, and now it's fine. Then plug in the battery, and it is charging. So for some reason, the BQ chip is not starting by itself. Okay, I think I found the problem. This is pissing me off. And actually, the manufacturer is not designing according with the datasheet. AC DRV pin, you can see it, is providing 25 volts to the gates. Actually, 6 volts difference compared with the main power rail. But you must have those two capacitors, yeah, between the gate and the source, and this is a must, because the freaking BQ chip is checking cycle by cycle if the if the MOSFET is getting shorted. Anyway, going back to our laptop, we have one capacitor on the second MOSFET between the source and the gate, but not on the first MOSFET. On the first MOSFET, we have a resistor, then we have a capacitor. This is a track which is going somewhere, and I have no idea where it's going. But anyway, in order to make it like the data sheet is looking, I have to short this resistor, right? Good. Let me connect the probe to ground. Yeah, so one more time. Plug in the charger, and after the first MOSFET, we have nothing But on the input of the MOSFET, which is this big track, we have 19. You can see? Good. Now, make it like the data sheet. The data sheet means I will short this resistor, so I'll have the capacitor from here to the drain, right? Yeah, it's not the source, sorry. No. On the first MOSFET is from the gate to the drain. So shorting the resistor, and check on the screen. You can see already it's taking like 10 milliamps, and it start charging the battery, you can see. Just to understand how crazy is this fault. I mean, it will be the same thing if I will desolder the capacitor, or if I will solder another capacitor there. Yeah, everything is fine. Unplugging the charger, plugging the charger, and it start charging. On the gate, we have 25 volts. So I believe that resistor was partial shorted, actually. That resistor is coming, yeah, from the other gate of the MOSFET, yeah. So here we should have 25. I didn't know what is that track, but that's what the track is going. So the track is going to the other MOSFET. So I believe this resistor was partial shorted. That's what I believe. Not sure why this gate need a resistor on the serial mode, but this was an insane job. So what we did, basically nothing. We found the low side MOSFET on the charging circuit in bar. We replaced the bigger chip for nothing. And yeah, we get rid of that resistor. On the moment we get rid of that resistor on the serial with the gate, it start working. But we check the voltage on the gate, yeah, on the both gates, we check the voltage was like 25 volts. So you see, this kind of fault is making no sense at all. I spent like 2 hours for a freaking resistor. Oh. So it's charging fine. I'm plugging the charger, plugging the charger back, and you start working. You start charging. Now let me put all back together and let's do a final test. Okay, all is back in place. Plug in the charger and it start charging. Pressing the power button, and the laptop it is coming on. And we have picture. We have picture. Look at this SSD has some LED activity on it. And yeah, everything is fine. You will see lines because of the refresh rate on my camera, but actually the screen is perfectly fine. There are no flickering on the screen. Yeah, my charger got disconnected because I don't have enough current. But everything is working fine, and we have the charging sign on the screen. All good. So it's working fine. Now, the GPU fan is not spinning. It's because it's not hot? Or why? Let's heat up the GPU. Yeah, it is spinning. Yeah, pretty nice design. When the GPU is cold, yeah, there is no point for the GPU fan to be on. Okay, perfect. So I'm gonna stop now. Was a very long job, and everything because of a resistor. I don't check resistors. I check voltage. I check current. We check the voltage on the gate. On the gate was 25 volts. Anyway, thank you for watching. Like, subscribe if you like the video, and see you on the next one. Hopefully you got something good from this video. Bye. Hey, If you find my content being helpful, don't forget you can support this channel by pressing the join button, and you can get instantly access to our members only cool collection and Discord private channels for support with your repairs. Also, you can have a look on our United Kingdom eBay, where you can find some cool and unique products, United States eBay store, or our Patreon page. Thank you.